The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of a 7-digit number involving alternative sets of zeros. Example, 4,06,500. As mentioned in the previous exercise, the purpose of taking a higher digit number is not to do the detailed calculation at every stage. As mentioned, when we go for higher numbers in square root, division, etc., there will be a number of calculations within the calculation. So for every such calculation, the child may use an additional abacus. We are not going for the details in these problems. In these problems, we are explaining the procedures involved in finding out the square root for large numbers. Now, in this problem also, we are not allocating the digits meant for the decimal calculation, as the existing abacus cannot hold the full set of calculation within 15 columns. So that is why we will start setting the number from the right end, and at the end, when we get the remainder, we will indicate that this is a number which is not a perfect square. Let us take the number 4,06,500 and set it in the abacus. That is 0 in the right end, followed by 0 to its left, 5 to the left of 0, 6 to the left of 5, followed by 0 to its left, another 0 to its left, and finally 4. Now for the purpose of calculation, we have to treat this as 4 as a single group, 0, 0 as the second group, 6, 5 as the third group, and 0, 0 as the final group. Take the first group, 4, and consider the perfect squares there. 4 is the only perfect square in 4. The square root of it is 2. Therefore, set the 2 by skipping a column to the left of 4. Now, 4, which is 2 multiplied by 2, should be subtracted from 4, and you are left with a 0 in the first group for calculation purposes. Now, you have to add the 2 digits from the second group. Now, you will get 0, 0, 0. In the next stage, double the number 2, which is the square root, and set 4 in the extreme left of the abacus. As the dividend has only zeros, the next digit of the square root is 0, indicating that we have 20 as the 2 digits of the square root at this stage. Now, we have to deal with 0, 0, 6, 5 in the third stage. Now, double the 20 and set 40 in the left extreme. At this stage too, the first 2 digits of the dividend are 0. We have to simply consider 0 as the next digit of the square root 2, thus making the 3 digits of the square root as 200. Add the last group of 0, 0 to this remainder, making it as 6,500 for getting the final digit of the square root. Now, double the square root 200 and set 400 in the left extreme of the abacus. We have not added any bead in the last 2 stages of calculation, but we have to remember that in every stage, the empty column is giving a value. Earlier, we started with 4. In the next calculation, we started with the 40 and currently we have to deal with the 400. Now take the first digit 4 of the divisor and the first digit of the dividend 6 and you get the divided value as 1, and therefore 1 can be treated as the fourth digit of the square root. Add this 1 to the already set 400 and the number becomes 4001. Now 1 multiplied by 4001 should be subtracted from 6500 and you will get the remainder as 2499. That means this number is not a perfect square. The square root that you have got in this number is 2001 and there is a remainder 2499. If you want to go for the decimal part of the square root, you have to simply double the square root 2001 and make it as 4002 and add 0 at every stage to the remainder and use the normal division procedures to find out the value. You can do this as a separate calculation. If you calculate the value subject to 3-digit correction in the decimal part of the square root, you will get it as 0.624. As indicated, the purpose of this problem is to explain the procedures and also revealing the fact that when we do problems like this, there will be number of intervening calculations before we arrive at the final calculation. Though this type of problem is not prescribed even at the school level, the purpose of practicing this is to give more experience so that the skills of the visually impaired child can be fine-tuned. Therefore, by adding the 3-digit correction of the decimal part of the square root, you get the square root of this number as 2001.624. So far, we have dealt with 5 digits, 6 digits, 7 digits, which are not usually prescribed in the school level. Most of the problems are confined to 3, 4 and maximum 5. Now, before we close this section, let us do one more problem dealing with the 8 digits number and let us demonstrate how we can find out the square root.